In this lesson, we will look at Unit 3, Section 3.1, Common Factors of a Polynomial. In this lesson, you will learn how to apply an area model for the product of whole numbers to develop models and strategies to determine common factors in terms of a polynomial. First of all, we're going to review what is a polynomial. This was first introduced in grade 9 in the Chapter 5 Polynomial section. A polynomial is one term, or the sum of terms whose variables have whole number exponents. Keep it in mind that if an expression has a fractional exponent, it is not a polynomial. It must have whole number exponents. So for an example, you can have 2x squared, subtract x plus 5. Each term is separated by either a subtract or an addition symbol, which is a polynomial. So each term has to be separated by an operation, and you need to have a whole number exponent. There are three types of polynomials. First, we have a monomial, a polynomial with one term, and is an example of 2x squared. A binomial, thinking of a bicycle, has two wheels. A binomial is a polynomial with two terms. So for an example, 2x squared subtract 7. And our last type is a trinomial. So a tricycle has three wheels. A trinomial has three terms. For an example, 2x squared subtract 5x subtract 7. And our last definition there is a term. That is a number, variable, or the product of numbers and variables. So we could have -2, x, or 5x squared. And as we mentioned earlier with the definition of a polynomial, a term is separated by an addition or subtraction symbol, and there could be one term in a polynomial, which is a monomial. There could be several terms, but to keep it in mind that they have to be separated by an operation to be a term. They could have a coefficient and a variable attached, but it has to be together. So we're going to look at how to multiply polynomials in this section, and we're going to use three strategies. The first one is going to be the use of algebra tiles, next the rectangular model, and then we're going to use the algebraic model, and that is known as a distributive property. So first of all, multiplying polynomials using algebra tiles. You've done a fair bit of work with algebra tiles from grade 7 all the way up to grade 9. And we're using an expression here, 3 times 2x plus 3. So we are multiplying a monomial with a binomial. And we're going to use algebra tiles in the shape of a rectangle to model the expression and the multiplication statement. So along the top, we're going to model 2x plus 3. Remember that the x variable is going to be a rod, and we will need two of those going along the top. To model the positive 3 ones, we're going to use the smaller squares, and we have all positive expressions there, all positive terms, so we're going to keep the tiles in yellow. Now going down the side, we have 3. We don't need to model 3 ones, but this is saying that we're multiplying 2x plus 3 3 times. So we will need 3 rows of the same of 2x plus 3. In order to get the answer, all we have to do now is to add up what is formed by the tiles. So if we count up the number of rods, we will have 6, and this will represent 6x. Then we will have 9 ones, or 9 of the smaller tiles, and that will represent 9. So the answer here will be 6x plus 9. Our next strategy is multiplying polynomials using the rectangle method. Now this could be known as the rectangle method, the box method, or an area model. And here is very similar to the algebra tiles, except that you use a rectangle. And along the top, there is going to be two pieces to your rectangle. You're going to put the 2n on the top and a 3. And we're going to put the 3 on the side. So it doesn't matter if you put 2n and a 3 along the side or on the top. It will keep your rectangle the same, except that your rectangle will be up and down instead of going across. So in order to find the answer here, we're going to multiply 3 times 2n which will give us 6n. Then we're going to go 3 times 3, and that will equal 9. So very similar to the algebra tiles, we don't use the tiles, but we're going to show the multiplication in a rectangle method. And the answer itself is actually shown in the rectangle. Our answer would be positive 6n plus 9. Our third method is the algebraic method, and this is using the distributive property. So just to refresh that property, for all numbers a, b, and c, we have the monomial a being multiplied by binomial b plus c. When we use the distributive property, we go a times b plus a times c. So what we're going to do with our question here in our example, we're going to go 3 times 2n, which gives us 6n, and 3 times 3, which gives us positive 9. So using the distributive property, the number outside, which is a monomial, is being distributed to both terms in the binomial. And in summary here, to multiply polynomials, the strategies below can be used. You can use any of the below strategies, whatever one you find the easiest, but it's nice to have a method to show it visually and to have something to use a little bit of algebra to display what you did in your symbolic model. So we have the algebra tile method, the rectangle model, and the algebraic method distributive property.